With Nagaro's diverse range of resilience engineering services, you can build robust and reliable systems and ensure business continuity. Our tailored solutions ensure that your brand has the unbeatable advantage of staying at the top, even during unforeseen events.
Hello everyone. I'm Rajdas, a senior software engineer at Harness and one of the Litmus kiosk maintainers. Thank you for attending this kiosk carnival 2023, and special thanks to our sponsors for supporting our community and this event. And I'm pleased to introduce Surya Bhagvat and Dave Johnston, who will be talking about building resiliency at Harness with kiosk engineering. Surya, the stage is yours.
Thanks, Raj. Thanks, everyone. Thanks for joining the session. So we will cover pretty much like what Harness has been through as far as the chaos is concerned. So let me share my screen. So I believe everyone can see the screen, right?
Yeah, yes.
Right. So I think by now you have attended many sessions, and probably the definition of what chaos is has been like communicated multiple times, right? So I won't have too many slides around what chaos engineering is. I mean, it's pretty much you just want to make sure that your service is resilient against faults, and that's the whole concept of what chaos is all about. Now, just because Harness has the module or the product around chaos doesn't mean like we jumped into it and we wanted to implement it on day one. Coming from SRE, it's in running things in production, and at the same time you want to embrace chaos is kind of challenging, right? Because on one hand, as an SRE, you want the production reliability to be of paramount importance, and uh, that's the goal for any SRE who is on call, or for any SRE who is on 24 by 7 or doing production deployments or any of this sort. The reliability is critical, and that means we want to meet our customer SLAs, and we just cannot whatever SLAs we have communicated to our customers that we will meet, we want to make sure that we meet those SLAs. And there will be some cultural challenges around implementing chaos as well as technical, right? Why break things when things are running well? Or why do you want to create more chaos or more trouble for an SRE or for an engineer on call? So these are the questions that kind of came to us as well when we started this journey of embracing the chaos. Now, but why should we, right? Why is it a good idea to embrace chaos? So some of the things as we piloted with one of the module is the reluctance is there, but actually embracing chaos has its own advantages. The very first one I would say is like for an SRE on call, you want as much observability and visibility into your production infra. And setting up the alerts, adding the monitoring, and all of those things is not one time job. It's not like you set it up and you are good forever. New services will get introduced, no code, new code will be added. So it's always an iterative process. Now, one of the interesting things when we did some of these basic chaos experiments was we thought when we brought down a pod or when we hog the CPU, we will see certain kind of logs and metrics in place, but we were surprised to actually see what we saw. So one of the advantages I would feel is like you would get much more understanding of your observability, of your monitoring, of your logging when you run these chaos experiments on a regular basis. And in the previous slide I had meeting customer SLAs. In this slide also I have the same thing. Now, if you have promised your customers four nines or 99.9, whatever your committed SLA is, you have to make sure that you meet those. You just cannot rely on hope, and that's not a strategy like Google SRE book says, right? Hope is not a strategy. You want to make sure that you try things in production, you try your load testing, you try performance testing. At the same time, you need to try the chaos testing as well. That's how you know, right? When an alert comes or when something happens, you know what exactly it is coming for. So if you want to meet your customer SLAs, have chaos in from time to time. And the culture of chaos, it's not it's not a it's not just a product that you have and you just want to start using the product. It's about the culture, like just how there have been like over the last 4 or 5 years all about SRE culture, embracing the SRE culture, right? Everyone wants to get away from the model of engineers writing the code, giving it to SREs. It's not it, and it's SRE's headache to run it in production. We moved away from that at Harness over the last few years. And anytime an incident happens, in fact we had a partial incident last night. Engineers drive it, engineers are on top of the alerts, engineers monitor the system. That's how we embrace the SRE culture. And once you start running these chaos experiments in production, you kind of get into the same model of embracing the chaos culture, shared ownership with engineers, with SREs, and so on. The last one is one of the interesting thing we put here is the cloud cost. Now, as an SRE, when you run things in production, you always want to make sure like things are reliable. And the easy way to do is you basically bump up your infra. You basically uh, anticipate some events, the load or whatever it is, and you say like, I'm going to give this much CPU to my pod, I'm going to auto scale, and all of those things. So what that happens, you kind of over provision the infra. And when you actually do these chaos experiments, when you bring down the pods, nothing happens. Even if you bring down 2 pods, 4 pods out of 8, then you realize like you probably over provisioned it by 50%. So this is one of the ways for an SRE or for the company to know like how to control your costs. So that's a side effect, but that's very nice to have in this kind of environment where the cost is of paramount importance. Now, how did we start off this chaos engineering? Like I said, we had our own reservations, and we started off with a small tiger team kind of thing. We took one of our product, the feature flag product, and we piloted with that. So every week, we had feature flag team running the chaos experiments at a predetermined time, uh, documenting the findings, documenting the observations, and so on. So we didn't start off like all things at once, right? Anytime when we start off with these chaos experiments, you start off small. So that's what we did. We started off small with very basic experiments like bringing down the pods. That's very basic to begin with. And then we started introducing the network latency between our core services to our cache, Redis cache. Then we introduced latency between our core services to our Postgres database. And Dave will cover what kind of hypothesis we had, what kind of actually what we saw, and whether it matched with what we thought we would see. So those experiments we started with, and then we started with subset of infra. We like with these chaos experiments, right? One of the good thing you can do is like if you have 8 pods or 10 pods or whatever infra you have, you can say you only want to do it for 25% of your pods to go down, or 25% of your pods to hog the CPU, and so on. So we started off with a subset of infra, and we usually did this during off-peak business hours. We still did this in production. We like in one of this sessions, someone mentioned, right? Like my pre-prod is kind of unstable. So how would chaos help there? So in the similar kind of model, what we thought was like we could run it in our QA environment. It will be useful to find out like all the logging, all the monitoring, and all of that. But to get a real picture of our dashboards, to get a real picture of our APM tools, of our logging, and so on, we had to run it in production. And we ran it in production during off peak business hours. So, this is how we started our journey at Harness. And Dave is the principal engineer on the feature flag module. He will cover like what all experiments we did, what all findings we found, and so on. So, Dave, the stage is yours. Thank you.
Thanks, Surya. just see if I can share my screen. Okay, hopefully everybody can see this okay.
Yeah.
We've got it. Okay, so as Surya said, my name's Dave. I'm the lead engineer on a module called Feature Flags at Harness. So we wanted to start a little bit of chaos. It was quite interesting to me. From a personal perspective, I'm responsible for the module and the quality of it. I'm also based in EMEA, so when I go to bed at night and our big customers based in the US and APAC come online, I kind of want to get a good night's sleep knowing that the system's resilient, that it's going to behave well. And if something does go wrong, the right alerts will go off so we can deal with it before it becomes a major issue for us. So the idea of being able to run these experiments in a controlled way really appealed to me. I think from our customer's point of view, if you look at how Feature Flags works, customers log into our SaaS platform, they create a flag, and then they embed an agent in their own application code. And when they toggle flags, those changes are pushed out in real time, and it's live. So some customers we have would be retail websites, and if you imagine on a holiday period, they can use these flags to turn on promotions. You'll see them pop up on the web page, and if that doesn't work, that can have a real impact on their business and a loss of revenue. So resilience is critical for us, and being able to be fault tolerant is important. Of course, we also know that all software does have bugs. So when it does go wrong, I think for us it's critical that we can be alerted and alarmed when it's going wrong, and we can take action and step in when we need to. That's one of the things that we find we just can't do with unit testing. As much unit testing and system testing as we build in, you can't test if the code failure will set off the alert you've set up in GCP. And that's where there's a real advantage with chaos, because it gives you the ability to simulate things that will happen in production and see how the whole thing behaves end to end. So being new to how chaos experiments work, we had to figure out what we wanted to do, plan our experiments. So we started by drawing up our architecture on a board and looking at the areas that would maybe likely fail or have a high impact if they did fail for us. So in the slide you can see here, we have a couple of SDKs at the top. So this would be our customer clients, and they connect into what we call a client service. So the job of the client service is to get the flag information, process the rules, and return a result to a customer. So we figured this is the kind of thing that can come under load if we get a lot of traffic. It's maybe going to get a lot of CPU memory usage. And what we wanted to ensure is that when it does come under load, it would behave correctly. So ideally, it would scale out, it would continue to handle load, and then if it gets to the point where it can't scale out anymore, some kind of alert would go off to notify us, and we could have a look and see what's going on. After that, we started looking at other parts of the system, the third-party parts of the system that we depend on, things like the databases and the caches. So we use Redis to cache data and speed up response times. If Redis fails, in theory, we should be able to continue functioning, but things would be slower. But we wanted to actually check, do we behave correctly? And then lastly, the Postgres database here, that was the most important part of our system. That's where we store all the flag information. Fundamentally, if it breaks, the system can't run. So we need to make sure we're tolerant, and we also need to get an idea if that was coming under load and if we need to take some kind of action. So as Surya said, we kind of tried to plan this small, simple experiments, partly for us to get up to speed on how chaos worked, but also to make it easy for us to run them week by week, in small windows when there wasn't peak load going through the system. And we could run these in production, we could see what happened, and then we could improve upon it. So the first one we thought would be really simple was the idea of the CPU hog on the client service. So the theory is, if we get a whole lot of traffic, our CPU will spike, and at a certain point, at 70%, we'll start to scale out horizontally. And eventually, if we've set a fixed limit to the horizontal scaling, we should start firing alerts. So setting this up is quite easy. In the Chaos Hub, there is a bunch of templates built around resiliency. The CPU hog was one of these, so it was a case of just picking that template. We were able to then set the labels for our service, and then we could just set the length of time we wanted the experiment to run for, and then what we wanted to do, so we could make the load go to 80%. So The ability to set the length these experiments ran for also was really critical, because as we started doing this, we wanted to do it for really short periods of time. We were running this in production, so we didn't want to run a 30-minute experiment, find out that we had made a horrible mistake and broken a lot of things. We were able to do it for a minute, observe what was happening, and then gradually ramp it up as we got more and more comfortable with this. So just before I go any further, what I'm going to do is just switch screens. I'm going to show you the experiment, and I'm going to kick it off in the background. Okay, so here's a list of experiments that we have set up in one of our projects, and we have the CPU Hog one. It's really simple, just to go in here, and then you can just kick it off. Okay, and I'm going to let that just tick away in the background, just to show you what's happening here. We have the service that's in question here. If I refresh that, you'll see currently there's not really much load going through the system. In fact, there's no real load. I'm going to go back to the slides, and then at the end I'll come back to this and I'll show you what actually happens when that experiment completes. Okay, so when we ran this for the first time, what we wanted to see is kind of what you see in this graph here. So what we expected would be a spike in CPU. The service would auto scale up, everything would be fine. What actually happened was we didn't auto scale, we didn't generate any alerts. The pods actually just started restarting. So we were really glad we were doing this at a quiet time, and we were targeting just one pod and not impacting production traffic. We're also really glad we discovered this through the chaos experiments rather than it happening for real. So we had to do a bit of research analysis to figure out what exactly was happening here. So it turned out the liveness probes were failing on our service. And when they fail, Kubernetes restarts the pod. And they were actually failing before the CPU got anywhere near the limit we'd set for the experiment. So it turned out our liveness probe was dependent on some pretty CPU-intensive functions. They were slowing down, the probe failed, and the pod started. So we took a look through the code. We figured out there was a couple of things we could do to improve things. So firstly, we could introduce timeouts. We also removed that code from the liveness probe itself and put it into the readiness probe. And that acted as a circuit breaker. So that actually meant when we got to the point when we were slowing down so much that we couldn't handle traffic, the readiness probe made sure that that pod stopped receiving new requests. Okay, so we improved the resiliency there. And we ran the experiment. And then when we actually reran the experiment, we got what we saw here in this graph. The system behaved exactly as we expected. It scaled up, and then at a certain point, we started getting alerts. So that was experiment number 1. Experiment number 2 was what I was calling the Sleepy Redis. So this is basically where the cache was either slow to respond or completely didn't respond. Now for us, the way flags works, the client will connect to the application. We get all the flag information out of the database, and this includes a set of rules that need to be processed and evaluated, and then we return that response. Because that can be quite slow, we put Redis in there as a cache, and we can serve the responses a lot quicker. Like if Redis fails, what we should do is still go to the Postgres database. We should still be able to get the data out. We should still be able to serve the responses. The only difference is it would be slower. But we wanted just to test and confirm that would actually happen. So just like before, we went to the chaos catalog. There was a pod network latency template, which seemed exactly right for us, and we were able just to configure it up as before. And the key thing here to set was the latency and the target service that we want to apply the latency to. So what happened? The experiment kind of worked for us. It worked in that we ran it, and during the window that we were running it, our service continued to work. It continued to service responses. We saw a slight degradation in service, but what we really got out of this was it wasn't clear what was happening. We couldn't really say that we weren't serving data from Redis, although it looked a little bit slower. We realized we had a bit of a lack of observability here. So through a period of maybe about 30 minutes, 40 minutes, we were able to put a profiler on the system, and we could see exactly what was happening. So we did actually time out on Redis, and we went to the database. But what we figured was if this was happening in production and there was a real incident, we didn't have enough information to tell us how our system behaved. So we spent a bit of time actually improving how we monitor these, and we started to build a dashboard where we have information on the Redis writes, the cache hits, and there that alongside the database, so we could actually see which of those was getting more activity. So we were kind of building our confidence about how much we understood about the system and our ability to debug the system when something went wrong. The third experiment then was very similar, but this time it was based on the Postgres instance. So as I said before, this is where all the data is stored. So fundamentally, if we lost Postgres, the system would fail. Now, we designed it in a way that there's replicas, so we continue to service traffic. But we wanted to know what would happen if it's kind of started to slow down, because if it did, potentially we would need to go in there. We would look at maybe scaling the database, adding more replicas, or taking some kind of action. But we needed to be alerted about it and know that it went wrong. So if it slows down, we should see logs that show the slow running queries, and alerts should fire. Just like the Redis one, we used to see a network latency template. We configured the latency. We actually initially picked a much lower latency than 20 seconds. We went for something quite low, like I think it was 4 or 5 seconds, and ran the experiments. Now, what happened this time was the first time we ran it, nothing happened. We didn't seem to trigger any logs. We didn't trigger any alerts. I think this is something we kind of find with the chaos experiments. You can plan your experiment and you can hypothesize, but sometimes you need to tweak and tune those. So we actually went back and we did what you can see in the slide here. We increased the latency to 20 seconds, so we were absolutely sure that this time something would go wrong. So we reran it, and we did get alerts, but we also got pod restarts. And it turned out it was actually very similar to our first issue, where again, our liveness probe was doing something that depended on the database. That timed out. The timeout on the probe was shorter than the DB timeout, and we got restarts. So again, we spent a bit of time improving how those probes work to ensure that the pod didn't actually fail. Instead, it just stopped servicing traffic, and we kind of got the alerts so we could step in and fix things. It also actually let us, we had deployed replicas, but this was again something we weren't able to test with system tests or unit tests. We were able to deploy replicas and then test to make sure that those replicas work. So when our primary Postgres instance failed, we could make sure that we could still read and service requests. We couldn't change flags, but it gave us some confidence that the system would behave and stand up when our database fails. So just before I go any further, I just want to switch over to the experiment that I kicked off. Okay, so the experiment should have run by now. I can go in and just see the latest results. So it's a pretty simple process. It sets up the chaos agent, runs the CPU hog, and then it does some cleanup. And if I look at this, you can actually see that there was a number of health checks and probes as part of this test. So initially it checks that the service is okay. There's a second probe that runs while the experiment's running, which just ensures that our liveness probes continue to return, that they're not broken. And then at the very end, there's a final one that actually checks to see, did we scale up? So there's just a little check here to see if the number of pods is greater than the original, which is 2. All this is green, it's all passed. And I've actually shown you the service, you can see what's happened. So a little bit like my graph, we've got this spike now, which triggered the scale up. So that was the initial set of experiments we ran. We ran them over a couple of weeks, and it's probably worth pointing that when we started this, we ran them manually, and we expected them manually. As we got more sophisticated, we started building those probes so that when we ran the test, they automatically give us an indication of whether it was successful or not. We're now at the stage of looking at more tests we want to add. So one of the tests we want to look at is actually running a load through the system. So every time we deploy, we can ensure that actually we haven't made anything worse. And then testing beyond the edge. So we really focused on testing our service running on SaaS. But we actually have these agents that connect to our system. So what we want to be able to do is actually start testing how they behave. So we can start to throttle and introduce latency and jitter to the network and make sure the agents that our customers take and embed in their applications continue to behave. So we want to make sure they use their local caches, they reconnect correctly. So it lets us do more than just looking at our own services. And then the last thing is really just automating these test runs. So we've done it with some of them. We kind of see it as a weekly fire drill where you run these once, you check your system behaves well, but over time you want to make sure that you haven't degraded or you haven't introduced any bugs. So we can just set these up with a simple weekly timer during a quiet window and make sure they run all the time, check the results. I think with that's all I have. I think it's time for questions from anybody.
Okay, all right. Thank you, Surya. Thank you, Dave. So we have a couple of questions. Probably I can add it to the stage. Yeah. So the first one is from John. How has chaos engineering responded to Harness CD? We are looking to adopt this Harness. We are looking forward to understanding some chaos engineering stories with Harness CD.
Sorry, I don't know if you have any thoughts on that one.
Yeah, I think Sharanya, can Matt take this? Can you call Matt into this? He's
Yeah,
interacting
sure.
with
I have
customers on. Yeah.
invited him to the stage.
Hey,
Okay,
Matt.
let me.
Hey, here I am.
Yeah.
Cool. Now I can help with this question too. So what's great, we have a native integration with Harness CD. So we're making it very, very accessible to our CD customers to add a chaos engineering step in the pipeline, just as Dave was kind of showing you as well, and the demos that we've had as well. But if you aren't a CD customer of Harness, we also make it super easy to integrate with GitLab and Jenkins just with our API. So, and some of the stories that we're shaping out are, automating disaster recovery testing, like Adrian was talking about earlier today, just as well as just making sure pipelines are protected against simple things like resource exhaustion, or even just tuning probes like Dave Johnston was talking about, because it's it's relatively easy to use probes and implement, but if you aren't testing and validating them, you aren't going to know that they work until you have an incident. So, but I'll let y'all move on to the other questions so Dave and Surya can answer those. Great job.
Definitely. Let me add the next question. Yeah. So, how did you ensure that your resiliency framework was effective and reliable? And what metrics or criteria did you use to measure success?
Yeah, let me take this, right? So, like I mentioned, we ran this in controlled chaos fashion. We just didn't randomly start experimenting in production and try to bring pods down or do the network latency kind of tests. So what we made sure was, like I mentioned, first we ran this during off-peak hours. That's the first thing that we did. And the framework itself, it's pretty straightforward to use. Now, you run your experiment, but what is more important is, like, you have your key service level indicators that that will impact your customers, right? We made sure that when we ran these experiments, these SLIs were within the thresholds of what we define. What I mean is, for example, like we ran an experiment about the CPU hog, and say some user on the CD side is running a workflow execution, right? We have a metric for that to measure, like, what is the threshold that we can take it to so that things don't break. So that's how we made sure, like when we ran these tests, that the things were working by constantly monitoring our dashboards, constantly having the visibility into the metrics, and making sure we run these experiments in a controlled fashion.
Sure, I think Amit has gotten his answer. Moving on to the next question. Um, yeah. So, uh, how do you ensure uptime while executing chaos in production? I think. Yeah.
So I think it's very similar to the earlier
Yeah.
question as well,
Yeah.
right? We ran it in control fashion. We made sure that the thresholds for the service level indicators or SLIs were within the boundaries that we defined, and those are the things that we took care of because we're starting off for the first time. But the goal is like to have this run on a repeatable fashion, to have the proper alerting in place when we ran these chaos experiments, and then act on it. It should not be an event. It should be something that just runs in the background all the time. And when it is alerting, we need to make sure that something is really broken. So we will get to that. Like we just started on this journey at this time.
Yeah, I think I would totally agree with that. I was pretty nervous about running these in production initially because ultimately we were a pretty new module. We wanted to make sure that we didn't impact any of our customers who joined us early on. So we watched it pretty closely. I think in the slides I talked about, we could set the test interval to 60 seconds. I think when we started, we even kept it even shorter. So we didn't kind of start straight away automatically running these as part of every deploy or on a automated schedule. It was very manual. It was very slow. So we got to the point where we were pretty comfortable. And now I would be fairly comfortable running a set of experiments we have, every time we deploy. Um, but you just have to take your time to get there.
Yep. All right. That's all. If folks, if you have any other questions, we can move the same to the Slack channel. And so the gaming sessions have already begun, and you can also move on to the sessions and win the prizes. And yeah, so I'll go ahead and end the session. Thank you, everyone. Thank you,
Thank you.
Dave and Surya.
Thank you
Thank
all.
you.
Yeah.
Thanks, everyone.